Please welcome our panel on why solving data edge cases is key to accelerating AI, with Shweta Shrivastava from Waymo, Vinesh Sukumar from Qualcomm Technologies, Dr. Itai Orr from Autobrains Technologies, and moderated by Sudeep George from iMerit.
Hi, welcome to this panel on edge cases, where we're going to be talking about how edge cases are extremely important in bringing AI systems into production. And we'll also be covering about some of the topics on how we can go about resolving these edge cases and use latest tools and techniques in order to make sure that these AI systems are deployed into the real world. I've got an expert panel out here who bring in a lot of experiences and perspectives across various industries, and they're going to be covering various points about edge cases and how they're being solved in production. So just to get started, an edge case is usually a situation or a condition that's outside the normal, but that's a very simplistic explanation. I think there's a lot of nuance to it, and that's where our expert panel is going to come in. And we'll start off with Shweta. Could you share your thoughts about edge cases and what do you think it actually entails in the industry?
Yeah, absolutely. So I work in autonomous driving, and autonomous driving, as you know, is all about the long tail and the edge cases. It's about solving that last 1% of the driving problem, as they say. So we come across unique and rare situations all the time. We've seen a drunk cyclist carrying a stop sign on his back. We've seen pedestrians in Halloween costumes, dressed as witches, ghosts, and whatnot. And we've seen a bubble truck driving past the park, blowing a huge wall of bubbles, right? So at this point, there isn't much that we haven't seen. But I think the more important question is, how you really define edge cases in your domain, right? And for AV in our case. And one important nuance to keep in mind is that rare is not the same as hard, right? So edge cases for us is about data scarcity, and hard problems are about the ambiguity of the solution space. So I'll give you an example, right? So we've seen instances of cars going at very high speeds in 20-mile-per-hour zones in Chandler, right, which is where we operate, one of the locations. You might call that an edge case, but drivers break traffic rules all the time. In fact, every 20 minutes in urban intersections, there is a red light runner, right? So you might be surprised about that, but it's a common occurrence. So I wouldn't consider these edge cases for AV, although some of these are hard problems to solve. So yeah, I mean, and another thing to keep in mind is, long tail cases may also change over time, right? So what's an edge case today is not necessarily an edge case tomorrow, or you might just see altogether new types of vehicles and objects on the road that you were not used to a few years ago. So.
Thanks, Shweta. Itai, do you want to share any thoughts around edge cases and your experience with it?
Yeah, sure. I totally agree with what Shweta just said. In our cases, I can add that we've seen many cases where road debris is usually broken down on the road, and it creates abnormal shapes that are not usually confined to a specific class. And this also falls under the category of edge cases, where you have unclassified objects or hazards on the road, and now you need to avoid them.
Okay. Vinesh, how about you?
Yeah, I think I definitely agree with pointers that Shweta and Itai brought to the table. I'll probably bring in a different perspective. As being at Qualcomm, definitely have the opportunity to really span plenty of verticals, coming from mobile all the way to automotive. And we deploy roughly, say, about 200 to 300 different edge-based models on any given year, right? But the classification of edge use cases could be quite simple as, searching for a photograph on a phone, to as complex as, maybe a level 4 or level 5 kind of autonomy in an auto environment. The bigger question that we face at this point of time is most of these edge use cases have been quite generic in nature, right? Now, can I really transition from more a generalization to more customization, right? So can I make those edge cases, which is very specific to the user, which is more about personalization independent of the vertical, right? So I think that's where in my perspective, is where the edge use cases are moving towards. It's more about customization and personalization, and less about generalization.
Thanks, Vinesh. Actually, that's a great point to make. And you also highlighted how edge cases vary across domains, right? I mean, what's an edge case in fintech and its repercussions and how they are handled is very different from how they are handled within the AV domain. So given this gamut of experience that the panel has on handling edge cases, can you walk us through how edge cases are typically identified once these AI systems are deployed, and how do you start handling them in the production process? Shweta, we'll start with you.
Yeah, I can get us started. So yeah, we're continuously mining for edge cases and areas of improvement. And we do that with automated ML algorithms, deep analytics, and user feedback from real world driving. Our primary strategy, though, is to gather the right data about the long tail, right? So we want to know what behaviors we need our system to improve at, so we can work backwards to generate the necessary data, and we can teach our system to improve in those behaviors. We obviously collect a lot of real world driving data. We have more than 20 million autonomously driven miles on public roads. But as you know, vast majority of the driving data is actually boring, right? Especially if you're driving on freeways. And there's no use gathering more miles about situations that your system is already good at, right? So we use filters and analyzers that can provide us targeted data for specific situations that we want to focus on. And then we complement the real world driving with tools like simulation and data augmentation. And we've made a lot of investment in that front as well.
Thanks, Shweta. Vinesh, how about you?
Yeah, so I think from a edge case perspective, I think that probably I would look at it as three categories. One which is basically commoditized. In other words, it's been in existence for quite some time, and how can you really polish, continue to improve the experiences associated with those use cases. And there might be a certain amount of edge use cases for which you physically know what the problem statement is, right? I'll take the infotainment segment of auto as one element, right? You really want to look at, let's say, driver monitoring or occupancy monitoring. And as such, you know exactly what needs to happen. And then, you really try to enable a certain application and a model of enablement to solve that use case. But then there's a vision statement, which is more towards the future, where you believe edge use cases are going to evolve, right? These days, a lot of conversations about metaverse and the definition of metaverse, right? There's a lot of use cases around metaverse. Those are wherein you believe it's going to be a problem in the future, and you really want to have foundational investment from an AI perspective to go solve that. Now, that is a very difficult problem to solve because firstly, you don't have data, right? So you have to really get into the world of synthetic data to really get that established. And you're going to have certain cycles of learning before you really try to establish how you want to get into metaverse. But when you go towards the commodity in the second category, wherein you know a physical problem to solve, I think it's a little bit of an easier problem statement. So in summary, I think, depending on the classification of an edge use case, I think the physical investment on MLOps or DevOps or data ops, as people call it, can really be different.
Thanks, Vinesh. Itai, what are your thoughts on this?
Sure. So our approach is having a very systematic and mature data pipelines. We heavily rely on our own internal vehicle fleets. And in addition to that, we also have access to our partner fleets and OEM customer fleets. So we have a large collection of vehicles all over the world that collect data. And then the focus is on really, as Shweta said, on collecting the interesting data. More of the same will not improve your system. The other way around, it will even hurt and create biases towards very benign cases. So data mining and efficient filtering is crucial. And you really need to place a focus on automated labeling and efficient data pipelines. Really removing as much of the human factor as you can from the entire process. The more you automated it, then your system will improve even faster. Once you found an out of distribution case or failure, then it gets root cause analyzed, understanding exactly what happened, if it's on the network, if it's on the post-processing, if it's on a sensor, if it's path planning, anywhere in the system, a solution is provided, and then you push it back to the vehicle and the cycle continues. So you get very efficient and lean improvements as you run your iterations. Now, I also think that this systematic methodology needs to be complemented, augmented with the right algorithms. Not every system and not every deep learning system can enjoy or improve once you have this automated cycle in place. And our focus at Autobrains is on self-learning and self-supervised learning. And we've created a method that uses signatures, and we essentially create a bottom-up approach that creates a general representation, and not only relying on high-level semantics, but we generalize to unclassified and I would say unclassified hazards and objects. And this allows us to create a more robust solution to those out of distribution cases.
Thanks, Itai. So you highlighted some interesting points about the work that you do at Autobrains, and you brought up unsupervised learning. So do you use different techniques around ML ops, ML data ops? I'd really like to throw this question out to the panel. What are some of the best practices around ML ops, ML data ops that your individual companies have arrived at, given the loads of AI systems that all of you have been developing? Really like to get your thoughts and experiences around that. Itai, do you want to elaborate a little more on the ML ops and ML data ops part of your development tool chain?
Yeah, sure. So I think it's very important to go back to the fundamentals and first principles in that regards, meaning that you really have to separate your test set and your validation sets and your training set, make sure that the R&D people are not mixing and drifting as they go along. So this starts at the fundamentals. After you have your basis set, then you can go on to more advanced stuff and have quantitative KPIs for pretty much everything. If you rely only on feeling and visual inspection, it will not take you as all the way. So really quantifying and having strict metrics for anything that you want to improve. And once you put those numbers in place, now you can track them over time and see how the R&D improves.
Okay.
Yeah, I agree with Itai. One thing in particular that he mentioned, which we totally have experienced, and we follow that same principle in autonomous vehicle development, is it is very important to carefully separate your training data and eval data, right? Otherwise, you are effectively grading your own homework, as we call it. And you have the risk of having false confidence that your system can handle new situations because you're accidentally training it for specific situations only, right? And one very common example of this that we come across is construction zones, right? So construction zones tend to be dynamic. They are there today, they're not there tomorrow, right? Now, if you train your system, or if you're not carefully splitting your eval and training data, you could accidentally train the system to always expect a construction zone in a given location, right? And then you're just building the wrong system. So I would completely agree with that point. I would also say that if you're handling a use case that's as complex as AV, then you have to think scalability and build for scalability from the very beginning, right? So we have tried to extend the average case solution to as much of the long tail as possible. So in our case, we believe that a generalizable, flexible model, which is trained on large data sets, is preferable to fewer and smaller systems in AV, right? Because we are building a generalizable driver that can drive in different driving environments, in urban roads, dense traffic, as well as freeways, and on difficult or different vehicle platforms like passenger cars and Class 8 trucks. So when that is the objective, and we're trying to make a system that can be generalized across different situations, then you do want to rely on high capacity models that have been trained with large data sets and a variety of data sets, right? And this is interesting. I would love to hear what Vinesh thinks about that, because earlier on he pointed towards edge cases and personalization versus generalization, right? So I'm particularly curious to hear Vinesh's thoughts on this.
Yeah, great point there, Shweta and Itai. As part of what you call every company's transformation from a model-centric view to a data-centric view, it really becomes quite important on what your foundational data really based on, and especially in complex environment like AV, as Shweta pointed out, there are going to be a lot of challenges on, do we have the right data set, and is it very generalistic, and can it be kind of spread across multiple geo deployments, right? And also across multiple, I would say, cityscape deployment. And obviously, one of the biggest challenges we have at this point of time is, do we have access to the right data? And if you don't happen to have access to the right data, can I fuse that with synthetic data? And if I fuse that with synthetic data, what would be the variables in that synthetic definition to really make sure to have a little bit more high probability of success, right? And auto environment is a very unique environment wherein it's not something you can deploy on the road and then see out what exactly is going to happen. Now, obviously, in a very limited capacity, you could do that, but your fail ratio is absolutely zero in this case, right? So it's becoming quite critical, to really look at, all corner cases. And corner cases, also, we have to use AI to really define what kind of use cases are. And that becomes, I think, one of the fundamental learning principles for us is, can I use elements of continuous learning when I put this deployment either in a fleet kind of an environment or a basic consumer kind of an environment? And can I learn along with the user? Can I learn along with the fleet management? And then try to see if I can make adjustments, to my model. Now, maybe it's an extension to it. One of the biggest challenges, at least personally, I've been trying to face in the AV environment is, how would you classify which data is good? Because obviously you want to get to an element of completely unsupervised. That's obviously the ultimate goal. But there's always going to be a user intervention on what data defines to be good and how do you define good as bad. So I think with time, as AV fleet gets a little bit more exposure and experience, I would anticipate things will continue to improve. And we're already seeing that with a lot of deployment as a transition point from L3 to L4, and a lot more use cases that are actually coming up to see, can I really solve some of these edge kind of models. Maybe as an extension for it is, maybe have one foundational model that solves pretty much all use cases around L4, and then make that foundational model to be more adaptive as it gets continuous different flavors of data. But again, you can always dream big, but let's see where we end up in that space.
Thanks, Vinesh. So you highlighted two important points, right? You talked about right data, and you also talked about a data-centric approach. I was just curious about, how the latest techniques and the cutting-edge R&D that's slowly coming out into play in terms of synthetic data or even generative AI. How does that help, various companies in mitigating this problem of edge cases? Shweta, I know at Waymo, you do a lot of stuff around synthetic data. Love to hear your experiences around that.
Yeah, absolutely. For us, simulation is extremely important. It's a very powerful scaling tool for us, and we've invested significantly in the quality of our simulation systems. And I would say that at this point, it's so advanced that we can generate fully synthetic data at real-world quality in our driving domains, right? So what we do is in simulation, we amplify the miles from real world to prepare our system for challenging rare situations. And then we also automatically synthesize scenarios and entire journeys to assess our system's performance. One important thing to keep in mind, though, is for simulation to be effective, it needs to be realistic, right? And we can have all kinds of discussion about what realistic means, but it needs to closely represent the environment that it's emulating, right, in order to provide accurate insights. Obviously, the simulation scenarios have to capture the edge cases, so by definition, they are creative. But if they are too surreal, then they could be quite misleading. So one way we do this is through ensuring sensor realism. So, for example, if our system is going through, let's say, spring showers in Detroit at sunset, we can recreate the raindrops on our sensors and simulate even the minute details like the sun angle and the glare. And another example is the behavior realism, right? So in our simulation tool, we develop various behavior models for other agents like pedestrians and cyclists and other vehicles to understand how the system reacts to the full distribution of behaviors that it can encounter on the road. But again, I think it's very, very important to make sure that the simulation and the synthetic data, they capture the edge cases, but they are still largely representative of the quote unquote real world.
Itai, what are your thoughts around synthetic data and generative AI?
I absolutely agree with everything Shweta just said. We face similar challenges, and the main one is traversing the gap between the domain gap between simulated and real world data. In any simulated environment, you always have some physics or behavioral nuances that are not modeled, that they exist in the real world, but they don't exist in your simulation, as high fidelity as you get. So this is a big challenge in traversing the gap. Obviously, the benefits of using simulation environment are substantial. You can create any edge case that you can think of, and as much as you want of it. But then you have to make sure that it generalizes to the real world. A very interesting approach that we are following from the computer vision and deep learning industry is stable diffusion models, where you can create very photorealistic images based on cameras or RGB cameras or other type of sensors. And this also allows to open up new possibilities that were not possible using previous approaches. And this goes back to our previous, the start of our discussion about automated labeling and efficient data pipelines. When you put the two together, now you have a very interesting approach where you can create very photorealistic images and annotate them in order to train your models.
Vinesh, any experiences around synthetic data at Qualcomm?
Yeah, I think synthetic data has been a quite important tool for us. As I mentioned, it's when you're not vertically integrated, let's say, into a platform, right? It really becomes important as how you really define your architectures, how you really define your software and tools to really be in a position to be successful when deployed. So, and when you have to really do that, it's quite important that you really look at elements of synthetic data. Now, maybe as an extension to synthetic data is, today synthetic data is very vision heavy, right? Which I think is great. But as you start going towards fusion, right? Can I really get, let's say, LiDAR plus, camera? There, I think the industry is still evolving, I would say, in that kind of a modality. And I think that's something we're watching out for to really see if, as we transition towards what flavor of sensors actually makes sense in the AV industry. Does only LiDAR make sense, only radar makes sense? Do we really need cameras? In those kind of answers, I think synthetic data really make a lot of sense, and really how you really position that. There's a lot of talk about generative AI. Obviously, the new big term in the industry today. If you're able to really use the advances in generative AI, even instead of a tool creating it, right? Like if I just visually represent using a voice, suggesting, hey, I'm looking at this specific scenario, and the generative AI is able to create that scenario for me rather than doing a simulation, that'd be fantastic. But that's again, an epitome of what you call a blue sky, and really get to that point of enablement.
Thank you, Vinesh. This has been a really...
I noticed that this panel is agreeing a lot. Maybe you want to ask some more controversial questions then. We tend to be agreeing a lot on all.
I would love to. We seem to have run out of time though. So thank you, everyone. It's been a very insightful conversation. I think we have time for one question that's come up from the audience. So let me just pull it up. So quick question about various learning methods. We have active learning, self-supervised learning. Any pros and cons with respect to handling edge cases with each of these different methods? Itai, we'll start with you.
Yeah, sure. So we have a lot of experience with self-learning and self-supervised learning in Autobrains. The main theme and the main concept is to create a general representation of your data, and then a bottom-up approach to create or unclassified clusters. Or unsupervised clusters. This way you create a more robust perception system, and this goes hand in hand with edge cases or correct identification of edge cases. I think you also need to take into consideration that if you want to run these type of system on your edge, you also need very adaptive and very small models, meaning that compute is always an issue. And you always need to find a low compute or low resource type of architectures. And this is also an area that we heavily invest in, and we try to create very efficient, very adaptive neural architectures that you can run parallel or several models at the same time, and this gives you consistency or consistency checks in order to verify if you encounter an edge case or a failure in real time.
Yeah, I would say in autonomous driving, it's safety critical to detect and predict open set objects, right? Especially moving ones, no matter if it's a walking T-Rex or a taxiing aircraft. And we have definitely seen the latter in freeways. So we've started leveraging motion estimation, which is a semantics agnostic task as a source of supervision for these objects. And our method takes the LiDAR sequence as input and obtains unsupervised auto labels to train a class agnostic model to detect moving objects.
I'll probably add a different perspective, right? A little bit more confidence on continuous learning, and I'll kind of map it to maybe a different vertical, the gaming industry. For good or bad reason, during the pandemic timeframe, game streaming became a very popular focus areas. One of the asks that actually came from a very strong application vendor is, there's a lot of contributions coming from audience, whenever you have these game streamers, and game streamers lose their attention span because they have to say thank you whenever people do donations. So they wanted to have an actual intelligent chatbot who can actually mimic and become your virtual assistant when you happen to have these donations. So we're kind of always toying around with this self-supervised / continuous learning, what actually works well. And we soon realized that the self-supervised learning in some form or way actually needed user intervention and was never successful. And continuous learning did help, but the continuous rate of learning was so, I would say, far-fetched, between 6 to 9 months of work to really get to a point where it was completely independent. Now, obviously, there's elements of where we can get things better. But what I'm going to suggest is there's always going to be pros and cons for both. Really, the question mark is, what specific segment you're looking for, what kind of use case you're looking for, especially when you really get into elements of recommender systems. Self-learning is very difficult, at least from our experiences. Maybe for a different kind of use case, this becomes a little bit more easy to implement. But I would say, map to use cases, map to what kind of networks, and then go from there.
Thank you, Vinesh. Last question. It's actually a pretty interesting question. So the audience member asks, will we ever see an end to edge cases and their effect on AI production? Shweta, let's start with you.
I think long tail will always exist. And as you scale and advance your system, you'll push further and further into that long tail, but it'll never go away. And I would say, especially for autonomous driving domain, where absolutely anything can happen on the road, even things that you couldn't imagine. So our primary strategy, again, here is to make sure that the system is able to handle the variety of situations that can happen in a diverse range of environments. I don't think we will ever get rid of the long tail. It could get into sort of newer types of rare cases, but it'll never go away.
Well, there's a joke in the AV industry that the long tail is job security. So I totally agree. I think that in the foreseeable future, we will have the playing catch up with the edge cases. And I think this goes along with the previous discussion on very efficient data pipelines, focusing on what's important and discarding what's not important.
Yeah, I think I'll probably add as a strong perspective. I don't think edge cases are going to go away for sure. Right, Qualcomm as a company has been really pushing for existence of transitioning from cloud to be on the edge for several reasons and several advantages. Now, obviously, depending upon what kind of use cases, it could be maybe a transition between cloud and edge, kind of a little bit of a setup. But our positional statement, and I strongly personally believe that moving towards edge actually makes a big difference.
Thank you, Vinesh. Thank you, everyone. That's a wrap.
Thank you.
Thank you.